here is an example of dividing complex numbers. We also want to write our answer in standard form. So here are the two complex numbers we're dividing. Oops. And what you do, the process for dividing complex numbers, is you want to multiply the numerator, this top complex number, and the bottom complex numbers, like multiplying by 1, same thing top and bottom, but multiply by the conjugate of the denominator. If you remember, the conjugate of a complex number is the exact same number, but change the sign in the middle. So 3 minus 2i, the conjugate would be 3 plus 2i. Want to multiply that on the bottom and on the top. The reason you do it is so when you take a complex number times its conjugate, you're going to get a real number in the bottom. Alright, so this is like two binomials, sort of. So when you're multiplying complex numbers, use the FOIL method. So this is actually kind of an example of multiplying and dividing. You have to use multiplying complex numbers in order to divide. So let's do that across the numerator. Negative 4 times 3 will be a negative 12. My outsides will give me a negative 8i. My insides will give me a plus 3i. If I multiply those two last together, I get a plus 2i squared. You can't forget that definition of I squared is negative 1. And whenever I have a negative, or whenever I have an I squared in a problem, I always write right next to it, above it or below it, negative 1. So I don't forget 2i squared is actually a real number. Okay, let's go across the bottom. 3 times 3 is 9. My outsides will give me a plus 6i. These insides, when I multiply them, will give me a minus 6i. And then those two lasts give me negative 4i squared. Remember, I squared is negative 1. Okay, across the numerator, remember that this I squared is negative 1, so I'm actually have a positive 2 times a negative 1, which is negative 2. I'm subtracting 2, so my real part is actually negative 14. That's a minus, or negative. Then my imaginary parts, when I add those together, you get a negative 5i, just like that. Alright, then across the bottom, look at these imaginary parts. This is what happens every single time you multiply a number, complex number times its conjugate. Those imaginary parts will cancel. So if I subtract 4i squared, I'm actually adding 4 to 9, which gives me 13. But you got to make sure you split the real part away from the imaginary part. So that'll be in standard form. So you want to divide each part in the numerator by 13. So negative 14 over 13 minus 5 over 13i. This is the answer, and it's in standard form.